Hey everyone, so in this video we are going to implement an open source observability stack uh, using Prometheus, Grafana and Alertmanager. So this is something which is widely used in the industry, and I'm going to explain how this whole setup works, and then we are going to implement this whole setup so that you guys could understand how things works end to end. So as you can see, there are a lot of things, but the most important thing is this Prometheus server. Again, everything is important, but bulk of the work is done by this Prometheus server, and then we have Grafana for visualization, then Alertmanager for sending those alerts. Okay, so let's start understand each of them one by one. So Alertmanager, as the name suggests, it is just for sending the alerts. There is no other functionality, uh, or there is no other task that is performed by Alertmanager. It just sends the notification. So we can configure different channels like email, or we can send alerts to SNS topics, we can send alerts to uh, Slack, or even to PagerDuty. So whatever channel we have, we can send those emails to those channels. So that is the task and the responsibility of Alertmanager. Then comes Grafana. Grafana is, as the name suggests, it is derived from the word graph. So it basically gives us a nice looking chart or UI of all the based on all the metrics or data that it pulls from the Prometheus server. So it pulls the data from Prometheus server, and based on that it uh, paints the chart and gives us nice looking charts and dashboards. So this allows us, not only us as a developer or engineer or DevOps engineer, but for other stakeholders to have a better understanding of the performance and whatever our system is doing. So this is what Grafana does. Then comes Prometheus, which is the backbone of this whole stack. So Prometheus, what it does is it scraps the metrics from the applications as well as the node, and then store all of that in a time series database, and then uh, clients like your Grafana or even any other client if you have, but for most part it is Grafana, it will then query the Prometheus server. Prometheus server then sends the response after fetching the data from the time series database, and then send it to Grafana, and then we have nice looking dashboard on Grafana. So for any application to be scrapped by Prometheus, it has to be mentioned in the target section. So there is this section where we specify the targets which this Prometheus server will scrap. So we specify the target and also the endpoint on which that particular application exposes the metrics. And once we implement that, specify the target and the endpoint, Prometheus scrap the metrics, pulls the metrics, store them in its time series database. So this is for the Prometheus. Then comes the application side of things. So for Prometheus to work, we have to write some code in our application as well. So let's suppose we have an application and we want to make sure that we have the metrics for the number of requests we get, the response or the latency, and then the number of requests which were failed and which were successful. Like whatever metrics we want, we have to write the code for that in our application, like Node.js application or a Flask application or Django application or Go application, and then expose all of them at a given endpoint, and that endpoint will be used by Prometheus to pull those metrics in the Prometheus server, and then based on those metrics and those data, Prometheus will then fire alerts, and those alerts will then be delivered by Alertmanager. we have to specify those rules based on which we want to fire alerts. Like if the CPU utilization is more than 70% for 5 minutes, fire this alert. Like if the error rate is more than 5% for 5 minutes, send this alert. So we specify the rules, and then based on those rules we fire those alerts, and those alerts are then delivered by this alert manager. So this is how this whole thing works. And now let's jump right into the VS Code. There we will implement this whole stack using Prometheus stack and Helm, and I'll show you how we specify the targets, how we specify the rules, Prometheus rules, so how we configure the channels for alert manager, and how we write the instrumentation or write the code so that our application expose those metrics to this Prometheus server. So all of that I'll show you in the code, and you'll be able to understand and implement this in your application, in your cluster as well. So let's jump right into the code. Alright, so let's start the practical demonstration. So what I've done is I've tried to give the exact steps in this readme file. You guys can read this and you guys can perform this practical on your side as well. So the only thing that you would need is to have a Kubernetes cluster. So in my case, what I've done is I have provisioned an EKS cluster, and I've also provided the commands to provision the EKS cluster, so you guys can try it on your side. So all you have to do is you have to run this shell script to create the cluster, and then once you are done with the creation of the cluster, which is this script, and then you need to run this shell script as well, because we need the CSI driver. This will the CSI driver, and then we need the application load balancer controller as well. So you need to run these two scripts as well. I have already done that, so I'm not going to do that. And once we are done with that, that means that we have a fully functional Kubernetes cluster, and we can continue with this practical. So I've also created a Node.js application and Dockerized it and pushed to my Docker hub, so that we could deploy this Node.js application in this in our Kubernetes cluster, and we could monitor that. So first thing first, what I'm going to be doing is I'll take you to the application code here, and I'll quickly show you the code so that you guys could actually understand what I'm trying to do here. So this is a Node.js application, and here I'm writing those custom instrumentation, so that here I mentioned that in our application we have to expose an endpoint, and that endpoint will be then targeted by Prometheus to pull those metrics from our application to Prometheus, right? That was what I said. So here we have this endpoint, and on this endpoint our application exposes all the metrics, and I'll show you what are those metrics. So the total number of requests that we got, and then HTTP response time, so the latency, and then the HTTP error, so the total number of requests that failed. So these are some of the metrics 1 to 3 that we are exposing at this particular endpoint. So this particular application, I have Dockerized it, pushed it to my Docker hub, so that we could deploy this application in our Kubernetes cluster and monitor it. Okay, so that is the first thing. So this is the application related code, the deployment. We're deploying this application, and then we are exposing this application on using this service, and then we are using this ingress so that we could access this if we need. Again, I probably might not try to access this on the browser, but if I need, I can. Let's see if time permits, we'll try to access it and generate some load. but that is something which we will see once we are done with the rest of the things. So in this folder we have written everything that we need. So let's start with this readme file. First thing first, we have to first create the namespace, which we can create using this YAML file, which is this one. As you can see, we are just creating a namespace called monitoring. That is what we are trying to do here. So let's run this command. Our first command, this will create the monitoring namespace, and then the second step is we need to create a storage class. I'll explain why we need storage class. Let's execute this command and it will create a storage class, which is actually this YAML file. It is creating a storage class of type gp3 and the name is also gp3. Why we need storage class? We need storage class because if I show you here, our Prometheus server has a time series database. It needs to store the data, and to store the data it needs a volume. So when we install this Kubernetes stack, it will then request for a PVC or persistent volume, and for that to work we need to have a storage class so that whenever it requests, it could provision that volume. Not only that, if I show you, I'll show you later. So the next step is we have to add the Kubernetes repo in our Helm, and then we have to install it. So you have to have Helm installed on your system. I already have that, but if not, you can install it. That's not a difficult task. And then what you need to do is basically just copy this command. Just copy this one first. Then we have to install this one. So and then the values.yaml, we know that for any Kubernetes or any Helm chart we have to specify the values, and the values we have for this particular Kubernetes stack chart is mentioned here. So it will create the Prometheus server, and then the alert manager part, and then the Grafana part. Along with it, it will also create some CRDs, which we will use later on. So let's apply this command. It will take some time, and so the Kubernetes stack has been installed, and with this we get some paths, and then some other custom resource definitions which we can use to configure rest of the whole stack. So if I show you the diagram, we have the Grafana, we have the Prometheus server, we have the alert manager, and now what is remaining is we have to configure one of these channels where we want to send the notifications. Like we can configure as many as we want, but in our case we're going to be configuring Slack because I want to send all the notifications to a Slack channel. Okay, so let's minimize this. Let's minimize this as well, and the next step is to apply this YAML, which is basically configuring the alert manager. So if I show you, this one is the configuration. In this folder actually I have this slack.yml folder YAML, and what it does is it configure Slack so that we could send the alerts to a Slack channel. So the Slack channel that I have used is called DevOps, and then we have to configure the Slack so that it could like the alert manager could send these notifications to alert to the Slack channel. So for this, what you have to do is you have to go to Slack and then create a webhook, and that webhook URL you can paste it here. I have done that behind the scene. So if you have any issue creating that, You guys can check out any video on YouTube. That's basically a very simple process. And once you have your webhook URL, you can just paste it here, and then the channel uh, in which you want to send these notifications, right? And then here are a few things which I want to explain. So here, as you can see, I have specified only one receiver, and that is my Slack channel, right? And we can extend this. We can add as many Slack channels or as many other receivers, like email or PagerDuty or any other channel where we want to send these notifications to. But in this case, I have only one, and that is Slack, right? And I'm making use of this alert manager config, and as you can see, my folder structure is such that even if I have to add more channels, like let's say I want to add SNS topic, I want to add or maybe PagerDuty. So instead of adding all of them in this particular file, I'll keep this specific to Slack as the name suggests. I'll add another file, and that will be for, let's say, pagerduty.yaml or sns.yaml. That this way it will allow me to add more channels, and the things become a little bit more manageable, right? And then I'll explain what this thing means. So the group by basically means it instead of sending all the alerts individually, what it does is it allows us to group them, and we can group them based on whatever parameters we may want. In this case, I am grouping them based on the alert name and the namespace, right? And then the group weight and group interval, and then the repeat interval. So these are three durations which I'll explain. So the group weight is basically, let's suppose a group gets created whenever an alert is received for the first time. It will then create the group based on that alert name and then the namespace, because we have these two parameters based on which we are grouping these alerts, right? So let's suppose we received our first alert for a given group. So it will wait for 30 seconds before pushing that alert to the particular channel. So before sending that particular alert to our Slack channel, it will wait for 30 seconds. In that 30 seconds, if it receives any more alerts from that group, then it will batch all of those alerts and then send them as a single message. This way it will not flood our channel with too many messages, and it will help us organize things. And then the group interval thing basically means it will wait for 5 minutes. Basically the time interval between two notifications for a same group. So let's suppose we send a notification for a given group just now. So after sending that notification, even if we receive more alerts for the same group, we will not fire them, and we will wait for 5 minutes, because the group interval is 5 minutes here. We can increase this, we can decrease this. Same is, we can increase this 30 seconds to 1 minute, or whatever is our requirement. And then the repeat interval is basically, let's suppose we fire an alert, and then how long will we wait before sending a reminder for that particular alert. Say, let's suppose a server goes down, and then we send a notification for that saying like this particular server is down. So obviously it will take time for the developers and the engineers to fix that particular issue, and we don't want to flood our Slack channel or whatever other channels that we have configured to be flooded with like the server is down message. Like we notified them once, and then we will wait for them to solve the issue, and if they solve the issue in this particular interval, 4 hours, fine. That means that we don't have to fire another alert or a reminder alert. If they fail to resolve, then we can say fire a reminder alert, and that is basically what the repeat interval is all about. So this is how we configure the alert manager. That is actually this part, from the alert manager to the particular service where we want to send these notifications. So let's apply this YAML. I'm going to copy this and let's clear the terminal and let's apply this. So it will create a custom resource definition, which is this one, alert manager config, and then a secret, because we are mounting this secret here. Okay, so this is how we configure the alert manager. And then the next thing is configuring the rules, the Prometheus rules. So let me show you here. Let's suppose that our Prometheus server is scraping those metrics from all the targets, but then it has to have the rules to based on which it fire those alerts, right? So next thing is to write those rules and then applying those rules. So in the rules alert rule, I have specified few rules, and let me explain those rules. So this one is the golden signal rules. Basically, there are 5 golden signals which are generally implemented, and it is recommended by companies like Google. And these are, if you implement these 5 signals, then it's more than enough. But if you really want to get granular, then you can implement further rules. But let me explain these rules, and then I'll move on to these one as well. So the first rule is we have to check like if the application is running or not. So this is basically the first rule. So if the application is down for 2 minutes, we will fire an alert saying Prometheus cannot scrap the Node.js app for more than 2 minutes. The app might be down. So that is the rule number 1 out of the 5 rules we have in the golden signals. And then the second one is error rate. So if the error rate is more than 5% for 5 minutes, or if 5% of requests are failing in the given time period, which is 5 minutes in this case, then that means the error rate is too high. We have to fire an alert. So that is the second signal. And then we check for the latency, and if the latency is more than 0.5 second for 5 minutes for 95% of the request, then that means the latency is high. We need to fire an alert for latency. And then we have another signal that is high traffic. So if we get more than 100 requests in 5 minutes, basically if we get more than 100 requests per second for the last 5 minutes, then that means we're getting high number of traffic, and in this case we are then firing the alert. Again, this 100 is something which we can change, right? This is not something which we cannot change. In this case I have kept it to 100, but if you want, you guys can change depending upon your requirement. And then the last one is the saturation, high saturation. So if the event loop lag is more than 200 millisecond, then we again fire an alert for this particular event. So these are the 5 rules, the golden, we call them golden signals. And then I have some rules which are related to pods. So this particular one is if the pod crashes, or if the pod has restarted more than 3 times in the last 5 minutes, then that means we are having an issue with a particular pod, and we need to check that. So this is pod crash loop. Okay, and then a pod was terminated due to OM out of memory killed. So if we have this event occurred in our cluster, then we'll fire an alert and asking for intervention, because out of memory is actually a critical issue and it has to be resolved. Then let's say we have a deployment and we have mentioned that we want to have like this many number of replicas for that deployment, right? But if the desired state is not met, then we can then again send a notification like or a warning saying that this particular deployment desired state is not met, and the current state is not met. So for that again we issue a warning. Then if one or more part is in pending state for 5 minutes, then we are firing an alert. And then this one is related to the PVC. Here we are saying that like the volume is PVC usage is more than 70% of the PVC or the volume has been used, then we will fire an alert like saying for this particular service the PVC usage has been more than 70%, so let's check this and either increase the volume or maybe remove some of the unwanted files or whatever logs that you may have that is accumulating the space. So these are some of the rules, and then we have some rules related to the node itself. So this one is basically CPU usage is above 70% for 2 minutes, then that means we are experiencing high CPU usage. And then memory usage is more than 70% for 2 minutes, then that means we are having high usage of memory and we need to check this issue. And then disk usage is more than 70% for 2 minutes, then that is again an issue and we need to check that. And then if a node is down and for 2 minutes, then that's a critical issue and we need to fix this. Like one of the node of our Kubernetes cluster is down for 2 minutes, then we need to check this and we need to make sure that either we provision a new node or the node or whatever issue with the node is, we have to resolve that. So these are some of the rules, and so I'm gonna apply these rules. Just copy. Again, one thing which I forgot to mention, I'm making use of this Prometheus rule, which is again a CRD provided by this Prometheus state, which we are using. So it will take some time. So now we have the rules created, so let's minimize this. So the next step is let's minimize these as well. So the next step is let me bring the image back. So we are done with this part, we are done with this part, we are done with this part, and what else is remaining? So let me bring this thing back. So let's try to access the Prometheus and Grafana in the browser. So for that, what I have to do is I have to apply these ingress. I have created the ingress for Alertmanager, ingress for Grafana, and ingress for Prometheus. So I'm going to apply this so that we could access them from the browser. If you don't want to use ingress, you can maybe make use of port forwarding, but I'll go with ingress. So I'm going to apply these ingress. It will take some time, so let it finish and then we'll come back. Okay, so let's copy this address. This is for Grafana, as you can see, Grafana ingress, and also copy this ingress URL for Prometheus. So this one is for Prometheus. So let's copy this and then paste it here. So this is the Prometheus UI, and in the alerts, if you click here, we should see all the alerts. Like these are the golden signals which I just discussed, and these are the alerts related to pods, these are the alerts related to the PVC, And then these are the alerts which it has. I mean, we got all of these built in Kubernetes stack. So it monitors the etcd, it monitors the alert manager itself, and it monitors the whole cluster. And then in the target health section, we don't have any target yet. In the service discovery section, we don't have any service. So the next step is basically we have to actually let's apply the YAMLs, or let's create the deployment for our Node.js app. This way we will then try to discover our Node.js app using the service discovery. So it has created a service, an ingress, and then also a deployment. So because we have the deployment, this was the deployment, and then we have a service for this particular app, and then the ingress so that we could access this from the browser. So we'll try to access it if time permits, but this is how we have created the app. Now the next step is to actually configure the service discovery, the service monitor, so that it discover our Node.js app. So this is the service monitor which is targeting this particular app based on the level which it has here. On the service it has this level, and let's apply this one actually. So just copy this command and then let's apply. So once we are done with the execution, if we refresh this page, we should be able to see our Node.js application in the target list, and the Prometheus should be able to discover our Node.js app. Target health, still not here. It will take some time, I believe, but it should come up here. Let's wait for some time. So now we can see that our Node.js application is now in the target list, and we can also confirm this by using this command, which is a promql command. And if we enter, we should see that we can see our Node.js application is running. So in this service discovery, as you can see, also it's also here. So it can monitor our Node.js application. If something goes wrong with our Node.js application, it can then something goes wrong with our Node.js application based on the rules, it can then fire those alerts to send those alerts, push those alerts to alert manager. Alert manager then wait for the group interval and whatever time we have specified, and then once that time is lapsed, it will then push the notification to the Slack channel. I have mentioned in the golden rules that if the Node.js application is down for 2 minutes, then I should get an alert, right? So what I can do is I'll try to bring this Node.js application down by deleting this deployment. How about this? So what I'll do is kubectl apply dash, not apply, actually delete dash f and then node app deployment. So I'm going to delete this deployment. That will bring our Node.js application down, and we'll wait for 2 minutes, and after 2 minutes we should get an alert in our Slack channel. So right now it is 20:47. I'm going to pause the video and we'll come back at 20:50 and see if we have an alert in our channel. So let's pause the video. Okay, so I waited for a few minutes, but I didn't get any notification in my Slack channel, and turns out that when you delete the deployment, that actually means that you have removed your whole application from the cluster. So when you remove your application from cluster, for that this particular expression is not enough to fire alerts in that case. So we have to change this a bit. We have to write it like this, which means not only if the application is down, but also if we remove the whole application, even in that case it will fire the alert, right? So we have modified this a bit. Save this one, and let's apply these alerts once again. What was the command to apply the alerts? Alert routes, this one. Let's copy this and let's apply them again. Okay, so we have the new rules. Let's check the dashboard. Let's refresh this, so we should see those new rules in effect. It will take some time. So let's try to bring our Node.js application down. What I'll do is kfly, not kfly, delete -f Node.js app, and then deployment. So I'm bringing the deployment down. So let me refresh this page. It is taking some time. So as you can see, we have this in a pending state, and after some time it will be in a firing state, and once this notification is fired, we should get this notification in our this DevOps channel. So let's wait for some time. Moment of truth. I could have generated some errors. I could have fired some requests to make the latency high. I could have fired some requests to make the high number of traffic, but because that would have taken some time for me to fire that many requests, so the easiest of all these was removing the Node.js application. So that is why I removed the Node.js application, right? Otherwise I could have fired some error some requests to the application, and that way I could have fired alerts for these as well. So let's wait. So our Node.js application is down and our alert manager is firing the alert, and we should get an alert in our this DevOps channel. So let me get out of the channel so we get this dot here. So in the meanwhile, what I'll do is I'll show you how to create this endpoint. So first you have to create a channel. Just click here and then create a new channel. I have created the DevOps channel, and then what you have to do is you have to come to this Slack API, api.slack.com/app, and then you have to create a new app here, and you can create either using the manifest or from scratch. So I click this one, and then let's say in this case we say my alert manager, right? And then select the workspace, create the app, and then scroll down to on the right. If you scroll down, here is incoming webhook, and then turn this thing on, and then add new webhook. Then you select the channel, like the DevOps or whatever channel you have, and then select allow. This way you get this URL, and you just copy this URL, and then you have to replace here. This way you have your Slack URL or Slack webhook where your alert manager will be able to push those notifications, right? So this is how you create this webhooks. I'm gonna delete this one, I don't need, because I already have. Let's click this button. Let me delete. This was the one which I don't need. Scroll down, delete. So yeah, we have deleted this one, but our man alert manager, this user is active, and using this user or this app, our alert manager will then send notification to our Slack channel. So let me pause the video for a while. Now as you can see that the status has changed to firing, and we should be able to see the notification anytime soon in our Slack channel. So let's check the Slack channel. So we have received one. So as you can see that the app is down. So what I'm gonna do is I'll try to bring the application back again. So if you bring the application back again, and it will do the same process again, check for continuously for 2 minutes, and if the application stays active for continuously for 2 minutes, then it will send another notification to this channel saying now the issue has been resolved. So that is another notification or alert which it will send to the channel. So let's pause the video and see how it behaves in a couple of minutes. So as you can see that this error has been resolved, as it is now green again. And let's check the Slack channel. We have received a notification and it says resolved. So this is how this whole Prometheus stack works. And there is actually one more thing which I want to show you, and that is the Grafana dashboard. So let's log into the Grafana dashboard. Let's skip this. The default credentials for the Grafana dashboard is mentioned here in the values.yml, and that was admin. User was admin and password was also admin. And then if you go to the dashboard, the biggest advantage of using Prometheus stack is that we get so many built-in dashboards out of the box. So we can check the Kubernetes cluster, the workload, the pods, and anything we want to check or we want to see, we have everything already pre-configured. So let me check this one, the nodes. So as you can see, it's not reflecting the data for some reason. Let's go back. Let's another one, try this one. Okay, for some reason it's also not working. Not sure what went wrong here, but generally this thing works. You get all the dashboards and everything already pre-configured, so you just need to check them. So this is how this whole Prometheus stack works, and I hope you guys must have learned something new in this video. So I'm going to provide all the GitHub resource and everything you need to perform this practical, and I hope that you guys going to perform this one and you guys then be able to implement and understand things end to end.